very large gap. So speaking of outliers, you want to note if any unusual features stick out. You should always mention any stragglers or outliers that stand away from the rest of the distribution. An outlier can be the most significant part of your data. If your distribution seems roughly symmetric, then stragglers are best regarded as outliers. But if your distribution is skewed, then the long tail that continues the skewness is part of the overall pattern of the data and probably not full of outliers. So that is a lot of information in these 2 bullet points. So what we're going to do is we're going to mark these 2 bullet points and we're going to write see back. And hopefully the pictures on the back of this paper are going to explain to us what this even means. So the first thing that I would like you guys to do is identify what you think the shape of the distribution is. For these 3 graphs, what do you think the shape of the distribution is? And really do it, family. Okay, let's just start from left to right. This first one is definitely left skewed. The middle one, I would say, is roughly symmetric. I would also say that this one is roughly symmetric. So I am sure that there are some of you sitting watching this lesson right now saying, why is this one not left skewed? So I'm gonna try to draw him as best as I can. I'm gonna do it quickly so that I'm not wasting a bunch of time. So here is a graph that is similar. Now, you could see this like that. And if in your mind you're seeing it like this, I can see how you would say right skewed. Sorry if I said left skewed just a second ago. However, when a distribution is skewed, you kind of see like a stair, I don't want to call it stairwell, but maybe it is. It kind of looks like steps or stairs. So if a distribution is skewed, what you generally see is the distribution gradually decreasing toward the side that it's skewed. So notice it doesn't just drop off and then all of a sudden pop up at the end like this one. If we draw a line over this distribution, it's kind of like a set of steps leading down to the right-hand side. Whereas on this one, most of your data is right here to the right of the graph. And then you have two weird points that are outside of the rest of the data. So I personally would say this is roughly symmetric because most of the data is here, and then these are two really weird points that are unusual and maybe don't belong in that data set, or maybe were just a really unusual observation. Like our shoe data. On our shoe data, if we look at just the teachers, we can see that most of the teachers own shoes between 0 and 20. Most of your data is between 0 and 20. And then we have these really unusual guys out here at 100 and 102. You would still say that this is left skewed though, because even though most of the data is here, look at how much data is coming out to the right. It's not like 1 or 2 points are outside of this area. Several teachers owned more than 20, but that doesn't mean or negate the fact that most of the data is in this area. So hopefully that helps a little bit. The reason that I would say that this guy is roughly symmetric is because most of the data is right here, and these guys are unusual. Same with this. Almost all of the data is here, and then one observation is all the way out here. So that is shape. Okay, I have somebody hanging outside my door, so let me help them and then I'll come right back. Okay, I'm back. I think the last thing that I was on was describing or explaining why I would describe these as roughly symmetric. So the next thing is how these are an example of these 2 bullet points right here. So what those bullet points were saying is, if you have a skewed data set, and notice like I was saying, this is kind of, I mean, there's a big drop right here, but this is also kind of like a stairwell. It's not a stairwell, like a set of steps. Like it's gradually decreasing toward the left-hand side. When you have a skewed distribution, this probably is not an outlier. So even though it's far away from where most of the data is right here. Even though it's far away from that, it is not far away from the other data values in the TEL. So when you have a skewed distribution, you typically don't consider any of these values in the skew or in the TEL to be outliers. For one of these to be an outlier, like it would need to be all the way far, well, not all the way farther away, that doesn't make sense. It would need to be much farther away from the next data point. So even though there's a mini gap right here, I should say just one gap. There's a gap right here. It's still pretty close to the data values in the TEL, so we would not consider this an outlier. Now on this one, because he's roughly symmetric and there is a significant gap between this data value and the next data value right here, we can say pretty confidently that this is an outlier. So all but one observation in your data set is from 0 to 10, and then there's a gap of 10 and then your outlier. So this would be an example of where it's pretty obvious you have an outlier. All of the data is over here to the left, and then you have one observation out here to the right. This is an example of where we would say it is not an outlier because he is pretty close to the rest of the values in the tail of this distribution. So then this one in the bottom middle is a mix of both. So this point is probably not an outlier. This point is probably not an outlier. He's pretty close to the rest of the data. There's only a gap, like one empty bin between the rest of the data and this data value. But then 3 bins away, well, this scale is weird, so I guess we wouldn't really know how many bins away it is, but it looks like 3 to me. 3 bins away is an outlier. So hopefully this illustrates a little bit how you would just look at a distribution. Notice we're just looking at it. We're not writing down really any numbers or calculating anything. We're just looking at the data, looking at where most of the data is, and then comparing that unusual point to where the rest of the data is. Hopefully this gives you enough examples to show you how to decide whether or not you think something might be an outlier. So in this case, not an outlier because it's a skewed data set and it's pretty close to the rest of the values in the skew. This one, definitely an outlier. There is a significant gap between where the highest data value is and then the unusual point. And then this one is a mix of both. I think this first one is probably not an outlier, but this one toward the right-hand side probably is an outlier. Now, like I just said, for these, we are just looking at the distribution. We're not writing down any numbers. We're not calculating median or anything. We're simply looking at the distribution and saying, this is what I think the shape is, and I think that point right there is an unusual point because there's a pretty big gap between that point and the rest of the data, or we have a left skewed distribution with probably no outliers. So that is different than actually going through and mathematically calculating whether something is an outlier. So you have this method where you can just eyeball it and determine if it is an outlier or not. And then you have this other method where you actually take data values and use those to calculate if a observation in your data is unusual enough to be classified as a legitimate outlier. Typically, when they want you to calculate whether it's an outlier, it is obvious. They tell you calculate, use 1.5 times IQR rule to calculate and determine if there are any outliers. Or they ask you to make a box plot, which we are learning in 2 lessons. So most of the time you're just going to eyeball it like we did here, but sometimes, and they will probably make it clear, they want you to actually calculate if there are outliers in the data set. So we are at 28 minutes. I think what I'm going to do is pause and potentially make another stop and then make a separate video for center and spread. In fact, if I can, I'm going to go back through and separate shape so it's its own video, outliers so it's its own video, just to kind of keep this lesson a little bit more manageable for you. So hopefully I can figure that all out and I can take this whole part out where I'm just telling you my plan.